Hey, now I'm going to switch gears and talk to you about sulfur. I have a pocket full on my phone of sulfur deficiency pictures. I cover, again, Indiana and Ohio, and I can tell you I have taken picture after picture after picture of sulfur deficiencies this year. Why? Why in the world are we seeing it? Well, there's a couple reasons. Number one, we're increasing our yields, so we're removing more sulfur. All right. Number two, we're cleaning our stacks. I'm not opposed to clean air. I'm happy about it, but there's some consequences we have to think about. Also, a lot of the newer pesticides we're using, by pesticides I'm talking about herbicides, insecticides especially, they don't have sulfur in them. Some of the old ones used to. So I figured we might as well blame something else on glyphosate, right? There's no sulfur in glyphosate, all right? And also, as we've moved towards more conservation tillage, we've immobilized sulfur in our systems, and I'll talk a little bit about that. This is the picture. I took this in Columbus, Indiana. This is a coarse textured soil. It's a sandier type soil, and it was cool this spring. And I saw lots of fields like this in Indiana, okay? This is a really interesting shot, okay? This is a government publication I pulled this out of from Purdue. It shows 1989 versus 2009, and basically that shows the deposition of sulfur in the atmosphere from coal plants, right? We have cleaned up our air. Now that deep red is greater than 10 pounds of sulfur it gets into our soil from sulfur. We've cleaned up our air. But for our crops, that comes with a price, okay? Now, it takes to graze about a 200 bushel corn crop, all right, it takes around 30 pounds of sulfur. 45 pounds if it's 300 bushel corn. That's how much sulfur is needed. And we'll talk a little bit more about the timing in a second, but let's do some quick math. If you think about it, okay, a 200 bushel corn crop needs 30 pounds of sulfur. You mineralize sulfur from your organic matter, okay? Again, we'll hit on that in a second. For every percent organic matter in your soil, you should be able to mineralize around 3 to 5 pounds of sulfur. That's how you get sulfur to your crop, mineralizing organic matter, all right? So if I have 3% organic matter soil times 5 pounds, that's 15 pounds. A 200 bushel corn crop needs 30. There's a gap there. Now, when I was a kid, we always used to say, we can get 10 to 20 pounds in the soil from deposition through rainfall. You saw that map. It doesn't exist anymore. And so we've started to build these gaps in our sulfur availability because we have higher yield, we don't have it in the rainfall, okay? And a lot of the insecticides and fungicides and herbicides we use don't have sulfur in them anymore. So we're starting to see this gap develop in our soils. So sulfur comes to the plant in the sulfate ion. If you see that as a double negative valency, that means your soil is negatively charged, sulfur is negatively charged. It is not held in your soil. Think about it like nitrate. It moves very rapidly. It's very mobile in your soil, all right? It's just like, if you think about it, think very much like you do the nitrate molecule. It remains in soil solution and gets to the plant in the water, just like nitrates do. Again, it's mineralization of organic matter. When you think about mineralization, I've got a slide in a second, all right? What does it take to mineralize organic matter? Heat, right? Moisture, aeration, bacteria to break that residue down. That's how sulfur gets into the soil solution to feed your crop, okay? And as I mentioned, each percent organic matter supplies 3 to 5 pounds for your plant. Those are the things required to mineralize that residue, to mineralize it, and make that sulfate ion available to your corn plant. I'm not going to spend a lot of time, but I thought this was interesting. The sulfur cycle looks a lot like the nitrate cycle, the nitrogen cycle. If you go back to school, it looks a lot. The blue is how it gets to us. The green is the form, and then the orange is kind of what happens to it. What can we do? Well, if you look, here's what I think is interesting. The orange is, you can see there's plant uptake, there's leaching, right? You see leaching there. And then also you see volatilization, right? See that over on the right-hand side? We'll talk about that in a second, and runoff and erosion, okay? We can lose sulfur a lot like we do nitrogen, okay? Here's what it looks like. Here's what sulfur does in a waterlogged soil, interestingly enough. We talk about volatilization of nitrogen a lot. Sulfur can also volatilize into a hydrogen sulfide gas. If you've stood in a wet field for a while and you're standing there and you get that smell like rotten eggs, okay? A lot of time, this is what you're smelling, okay? But again, the consequences, think about, to me, I think we're walking some really fine lines as it relates to sulfur in our soils. And if we start having these waterlogged soils and we start gassing off sulfur, it's another penalty that's really has a big impact on what we do. Okay, sulfur, you know it. It's, we talk about the primary nitrogen, potassium, and phosphorus. Whew, boy. Then the secondary is calcium, magnesium, sulfur, okay? It is a secondary, it's not a micro, it's a secondary nutrient, all right? It can be absorbed as sulfur dioxide through the pores, the stomas, okay, but that's a low percentage. It mostly comes through the sulfate ion. Here's what I really want you to take home from this, those last two bullets. Sulfur is very important in chlorophyll formation, okay? Sulfur and nitrogen are very, very intermingled in the plant. Their ratios are very important, but sulfur is very important in chlorophyll formation. That's why when we see sulfur deficiencies, what's the color we see? Light green. We see that light green, okay? The other thing I think is really interesting, sulfur is a little different than a lot of nutrients in that more sulfur is taken up later in the year than most other nutrients. 52% of sulfur is taken up after R1. So think about that for a minute. It's very mobile, and it's taken up late in the year. So what do we think, as we start thinking about plant health, we think about sulfur being very important in chlorophyll formation, we've got to make sure we're providing sulfur late in the year to that plant to keep it healthy, to help with chlorophyll formation, okay? The other thing I would tell you, and this is where that ratio, we talked about the relationship between nitrogen and sulfur is very important. Sulfur is very important in the formation of nitrate reductase, okay? Interestingly enough, your corn plant takes up nitrates. Once it does, it has to convert it to ammonium in the plant to utilize it and break it down. So what happens? That's done with an enzyme called nitrate reductase, okay? And this is where the sulfur-nitrogen relationship comes in. Sulfur is important in forming nitrate reductase to convert that in the plant. Now, what we're telling you this morning, what Greg talked to you about, is we want to feed that plant a lot of nitrogen late in the year, which we do. But I also just showed you sulfur is taken up late in the year. That's that close relationship because you have to have sulfur in that plant to convert that nitrogen to a usable form via nitrate reductase. So I guess what I'm telling you is if we're going to keep these plants healthy late in the year, we need to start thinking a little bit differently about when we put on our sulfur because it's mobile and it's used late and how we apply it. The other thing about nitrate reductase, which I think is kind of an interesting point, is that in dark conditions, under stress, okay, nitrate reductase drops. The production in the plant drops. Well, think about when Greg was showing you 50,000 plants in twin 20s. What did he show you in the canopy? It's dark, right? So nitrate reductase drops in those conditions, okay? So if we have sulfur deficiencies, it's a double whammy, okay? So as we start pushing our pops and narrowing our rows, sulfur becomes even more important. Here's the thing I'll tell you, there's lots of sulfur fertilizers, but the thing I want you to understand about elemental sulfur, it's fine, it works, it does what it says, but elemental sulfur has to be broken down over time. The corn plant takes up sulfate, all right? Elemental sulfur has to be converted to that sulfate form over time, so if you're going to use it, you can't use it late in the year because it has to be broken down. The other thing I would tell you is, as you think about sulfur and its conversion, elemental sulfur and its conversion, there is a bacteria that does that in the soil. Interestingly enough, and this probably makes sense to you, it's more common in lower pH soils, that bacteria, than it is in high pH or alkaline soils. So sometimes we see some erratic responses to elemental sulfur applications, and that could be why. That could be why, because the conversion could be erratic as well. I'm just going to show you, I'm coming down the home stretch here. I thought this was really interesting. You can see the dates in 2006, 7, and 8. Iowa State did a study on sulfur. And what they did the first year in 2006, they did 6 sites, I think it is, right? 5 of 6 sites. They saw a significant response. The response was, 38 bushel. The other location, the 6th location, they saw an 8 bushel response, but that wasn't statistically significant. That surprised them. So in 07 and 08, they took it more locations, okay? They expanded the number of research locations, and I thought the data is really, really interesting. Here's what I would say. Look at where it says broken out by soil type, and I think this is really interesting. We talked about how sulfur gets into the plant. It's mineralization of organic matter, right? Look at the coarse textured soils. This should make perfect sense. The response on the coarse textured soils was much higher than the fine textured soil. Still a good response, but that's using gypsum that had to be mineralized over time. Here's what I'm saying. Okay, as we think about it, there are fields, this field, other fields that have coarser textured soils, lower organic matter. I think we really need to be thinking about how do we get sulfur into the plant to help feed that plant and keep it alive? So let's bring it all home. S deficiencies are more common. Sulfur is highly leachable. It's mobile in the soil. Most soils typically cannot provide enough. Some can, but not many, can provide enough through mineralization, so we have to supplement that. In a year when you have like this year, where we had cold, wet, low oxygen soils, we didn't mineralize much as well. Okay, so that was a double whammy. And over half of the sulfur is taken up after R1. And there's a strong relationship between nitrogen and sulfur. Okay, I'm not going to take you through biology class, but here's why I want to bring this all home. That is photosynthesis in a corn plant. And you remember I talked about nitrate reductase, okay? Converting that nitrogen. Just here's what I want you to understand. The green thing there, that's chloroplast, right? That's chlorophyll. Guess what one of the components of chlorophyll is? Nitrogen. You see all those enzymes up there, NAD, ADP, ATP, and NADPH? Guess what they have in their construct? Nitrogen. Nitrogen is part of their constructs. You see that enzyme up there called RUBP? That is the most common protein in a plant. Okay? It's actually believed that when corn plants start to get low on nitrogen, they pull nitrogen from RUBP. Okay? It's called Rubisco. I'm not trying to give you a science lesson, but here's what I want you to understand. If we run short of nitrogen and we run short of sulfur, okay, we start getting penalties, because look what's coming out the other end of that cell, sugars, right? And if that plant starts running low on sugars, it's going to go get them. These modern hybrids are programmed to yield. That's what they do. That's what they want to do. So they go get it from somewhere, okay? And here's where they get it. Aaron Galt, you sent me these pictures this week, right? Look at the difference. If you look at the top versus the bottom, the stalk cavitation, what do you think's happening in these fields? You're seeing, right? They're robbing Peter to pay Paul. That's the bottom, bottom three nodes, internodes of that plant. And you can see as it starts running out of nitrogen, and I would contend in a lot of cases where we're running low on sulfur as well, it's a double whammy. And these plants they're going to get the nitrogen and they're going to get the sugars to fill the air, because that's what they're programmed to do. But as a result, you're going to deal with it later. I would strongly encourage you this year to go out and start looking at some of your fields, start splitting stalks and see what you see, okay? Because I think this year with all the rainfall, with the higher demand late we talked about, I think there could be some issues. Okay, wrap it up. Jordan Spieth, he's the #1 ranked player in PGA, right? Jordan Spieth has like a 68.8 stroke average. He earned $9+ million this year, won 4 major tournaments, okay? Sergio Garcia is ranked 33rd in PGA. He has no major victories, all right? He's 0.8 of a stroke behind, on average, behind Jordan Spieth. He's won about $2 million this year. Webb Simpson's ranked 53rd, all right? Webb averages a stroke and a half more than Jordan Spieth. He's won about $1.5 million, okay? I guess my point is today, as you go through these sessions and you listen, figure out a way to improve your score by 1 stroke. It doesn't take a much. That's the fine lines. And maybe the fine line in your field is sulfur. Maybe that's the stroke you can pick up, okay? But be thinking about these fine lines as you can gain a stroke and really increase your bottom line. I love this quote from Abraham Lincoln. He gave this during his 2nd annual message to Congress. If you know, that was kind of a tough time in our nation. And I loved what he said. He said, "The dogmas of the quiet past are inadequate to the stormy present. The occasion is piled high with difficulty, and we must rise with the occasion." Think about agriculture today and what we're doing, all right? As our case is new, so we must think anew and act anew. And I would contend, as we think about agriculture today, right, it's piled high with adversity. We have to deal with these things. The world is changing. Hybrids are changing. More rainfall. And we've got to think new and act new to start addressing it as we move on.